Good morning to everyone, or afternoon or otherwise, depending on where you are located in the world today. Today, we want to thank you for joining us for our first webinar in a series of presentations on Advanced Steel. Today will be an overview of the Autodesk Advance Steel product. We invite you to give this product a try as you learn more about it this morning if you haven't had the chance to see that. Want to make sure that everyone can hear me, so if you would please indicate from your dashboard if you're getting audio just fine, or otherwise send a question to us or a chat if you are unable to hear. Maybe there are audio issues, or at any point during the webinar, please do so. But you can signify by raising your hand, if you would, that you are hearing everything okay and the broadcast is coming through. We do have a PowerPoint right now showing, so you should be able to see something on the broadcast at this point. I'll give it a moment for people to reply. Looks like just about everybody is hearing us just fine. That's good. Again, please let me know if the audio cuts out. I'll try to keep an eye on the dashboard as well as the presentation all at once. And please, if you do have some questions, answer at any point through the dashboard itself, and we will get to those in time. If we don't get to them all during the broadcast this morning, we will do our best to follow up with you. We do have the attendee list and some email addresses that we can contact you. Let's go ahead and begin with our broadcast here. A little bit about us, Cassoff Consulting. We are an Autodesk reseller. We specialize in several of the products, and want to make note, we're very proud that at this point this year we have reached 25 years of partnering as a reseller with Autodesk. Autodesk being the manufacturer of so many of the products we use, and all of our design suites or single point products, depending on how long you have found yourself using AutoCAD or otherwise. I've been with Autodesk software since '88, so I got to start around release 10 of AutoCAD. These days I specialize in a lot of the fabrication-based products as well as BIM tools, whether they be services in the cloud such as the BIM 360 offerings, or CAD MEP on the fabrication side for HVAC, Advanced Steel, which we're looking at today for steel detailing, and of course Revit. I do a great deal of information with our parametric modeling tools for the building industry. As far as Cassoff Consulting goes, we offer a large range of consulting services, whether it be training, mentoring. We do a lot of professional service modeling at times. We help out contractors and construction managers. Do a lot of work that varies through all the different products that we do support. But as far as Advanced Steel goes, being a bit of a newer product, you may be familiar with Autodesk's recent history when they acquired a product called AutoCAD Structural Detailing. That one, by the way, is kind of going by the wayside. The Advanced Steel product has been developed in partnership with Graytech initially, and then Autodesk acquired that and has been developing the product through the last couple of releases, really adding a lot of features that are highly beneficial to the steel detailer. We see that we're targeting several industries. You know, some of the images you see on the screen right now, whether you be dealing with miscellaneous steel or specialties, stairs and railings, or if you're in the oil and gas or the plant and mining industry, even electrical transmission towers, as well as, of course, building vertical. But Advanced Steel is really focused for the steel detailer, not dependent upon your industry necessarily, but the ability to be able to do connection design and detailing and automated documentation, as well as pushing output to fabrication. We'll see briefly this morning that we can create CNC files, DXF files. There are different associations of import-export capability. We see that it's all based upon a familiar AutoCAD platform. So if you're coming from the AutoCAD world, this should be very easy to ramp up for you. It's one of the real benefits of Advanced Steel, in that if we're already familiar with AutoCAD tools and processes, we can move right into steel detailing with a lot of the connection macros that were provided and the automated processes for sharing and exporting our data and doing automated documentation. It is a dynamic modeling tool. We like to call those things often parametric. Some people tend to argue that it's fully parametric, but I think that comes down to the user themselves. What is it we want to get out of it? Sometimes we need some very specific and customized connection detailing, and we're able to create custom connections and such. So in that case, it may not always be what we call a full parametric tool, but there are parametric values and capabilities inside of that. So it is a dynamic modeler. It is intelligent in that we will see that we have a lot of data built into these. I'll bring up some of the properties dialogues, and we can look at those to see what kind of data is actually included within our model components. We are provided what we call a connection vault. It gives us a lot of predefined macros that drive steel connections. We can do clash checking for our steel detailing material in here, while at the same time we can actually send things out to what you may be familiar with in the kind of pre-construction world where we use Navisworks quite a bit. We can do clash detection out there as well. But our clash detection tool inside of Advanced Steel is primarily looking for things that maybe is a good checking, in that I haven't got all my connections done. I'm seeing beam flanges that are not yet coped. I'm having members run into other members. So it's effective for that in helping us with the completion of our full project. And as far as workflows go, we're planning to have a few other webinars, and we're going to focus on kind of integration with other products. So Revit, whether we're dealing with robot structural analysis, certainly Navisworks, that's one of probably the more popular ones. BIM 360, I mentioned things that I'm involved with. BIM 360 Glue is like the idea of having Navisworks in the cloud. We're having real-time, accessible collaboration by multiple team members. We can upload our steel detailed models right there to go along with the other trades for that stuff to be checked and reviewed by all parties. The fact that we can create bills of materials, automated drawings, and then CNC data for DXF and our other extractions that can actually drive our fabrication process, our punching and our cutting, whether we're dealing with plasma cutters, water jets, whatever it may be, and we're creating all of that data that goes along with that. And we can use this in a multi-user environment, so we're not just stuck in a silo as a single detailer, although that is not uncommon. We see detail shops that have multiple users on board, and each of them may be working on their specific projects, but it is possible in a single larger project that requires more detailers. We can add that in a multi-user mode. All right, as far as our modeling goes, a lot of the concern at times with modeling is that it takes longer. Well, you have to look at what do we get out on the end result from the effort of making a model. We've moved a lot of our processes these days to a modeling approach and workflow, and it's the idea that we can get this other data, this intelligent data we want to build into our models and our model components. We want to take those things and do other things with them. So it's kind of like the idea of how much of a bang for the buck can I get out of this? If I want to make a single effort, I want to get multiple benefit from that. Often with the programs, I'll tell students or customers I mentor that if in certain cases where you're only going to see this and get one benefit out of it, sometimes it's best to just draw a line, and there's nothing wrong with that. We've got AutoCAD here. We can draw that line where we need to, whether it be a custom scenario or possibly a way that I'm not ready to model that as of yet. But I want to get more out of that. So if I can get a bill of materials schedule out of this, if I have a model that I can share and collaborate and clash check, do joint design, do automated drawing, that's the reason we look at modeling. So what we're going to see with these connection macros and other processes is that we have a lot of this stuff built in for us. We're going to have things that we give us that multiple benefit as an end result for moving into a 3D modeling approach. We'll see that it is possible to create general arrangement drawings. We do shop drawings for both single part and main part assemblies. We can, like I said, generate bills of material, CNC data, and it's all put together in a document manager that we can review. And as changes occur, if that's kind of in your mind, is that, well, what do we do when we have changes? is that we would see the program will actually manage that for us. If we define what the particular revision may be in that case, then it will actually put revision clouds on for us and so on. All right, well, we don't need that one. Let's move over to our product at this point, and let's begin to look at the Advanced Steel user interface and some of the tools and features that are provided for us. You'll see I'm on top of AutoCAD 2016 right now. It is a vertical that sits on top of this. If we look at the ribbon, you'll see differences of tool names and buttons and commands, panels where we see things grouped together. We have these tool palettes specific to the Advanced Steel product. We have, as we're going to be looking at, the connection vault. In the vault, we have different connection macros such as base plates, end plates, embedded plates. We have beam connections. We have moment connections, several different kinds of things, bracing, stairs, rails, and various items. They're going to help us actually make certain connection definitions in here. We have, with our other palettes, we have the capability of doing general assembly drawings. So these are drawing styles that are built into this. We can make our own defined and custom drawing styles within Advanced Steel that allow us to get the drawing output to look exactly like we want it to. Doing details, single part drawings, any of those are also used inside of what we call the drawing processes. The drawing process is like a collection of drawing styles. We're pulling out automatic prototypes we want, whether it's an A, B, C size sheet of paper with our title block or maybe another customer title block that we need to use. We can define those in part. There are different tools in order to set these automated procedures up, whether by views or so on. Well, we would learn about things called cameras and model views and different ways we can set up the management of the model to generate these drawings. We can create all single part drawings at once. We can create them by just selecting a few, which I'm going to be doing a couple of those. We have main part drawings that can be generated, either the entire model all at once, which I would hesitate doing because I have a lot of assemblies here, and it would take quite a long time for me to get this put together, several minutes in fact. But I can make selections and generate drawings as well. And then the last of my palettes, what we call templates. I have different types of BOM schedules I can create, whether they be summary lists, cut lists. We might find other materials, bolt lists, even one I'll create for you, which is like saw cut list or saw cut list with pictures. We'll look at a few of these this morning to see what gets generated from our model. But let's jump back here a little bit. Again, with AutoCAD, we can look at this in any visual style we like. Often many detailers like to work from a 2D wireframe mode. I'll avoid that as much as possible this morning because it's a little better for us to see something in a shaded or realistic presentation, and I'll do that. But here you can see, even as I zoom in here, and you start to see some of the items in this sample file that I have, already certain connections have been assigned to these parts and pieces, these beams attaching by clip angles or whatever the connection definition may be. We see a few bracings. If I pull out far enough, you can see that there are some concrete items. I'll add a concrete pad for us in beam, and especially other shapes we could add, like a concrete wall, whether it's representing a tilt-up or cast in place. And I have embed plates that I'm wanting to detail out and develop connections for. I can have those elements placed in my model and actually get it to do and cut voids and create things for me so I get an accurate representation of that embed condition. All right, let me just jump in here first off, and let's see as far as modeling goes. We've got a lot of beams, columns, and brace elements here, some base plates and so on. You'll notice that in the view I'll select these kind of one in turn, and you'll see that we've got a few line items. So we're going to create beams in a couple of different ways here. All right, so I can create a beam element just simply by modeling point to point. I'm very familiar with what we might do in AutoCAD. All right, and I'm not having to have anything in specific elevation other than what that line is representing. I'm really just tracing in part a 3D element. And once I place that element, I get a property dialog box for me that I can begin to redefine what that section may be. Just remembering what the last section was that was chosen, or a preferred default section. I could choose any size that I need for that particular design. If I needed a different section, maybe it's a tube steel, it's a channel section, I have a full database of profiles. We even have countrification if you're working outside of the United States. I have a full Australian sections. We have Canadian libraries, UK libraries, as many as we're likely to run into. You're going to find those. As well as we have the capability of creating our own user profile shapes if we have something unique. So I can pull down any of these from the list. I can choose from the current library that I'm accessing, and I can define what particular section it is. I can define what is the positioning of this. Here I'm moving it to top center steel. We have rotate and other offset capabilities. Note that right now in my naming area, I have not defined any single part marks. This is going to come later in my process. I'm going to be modeling my structure and my frame, and then when I'm ready to do so, I'm going to number all my parts because that's how it talks to the documentation and the export process. We can look quickly through any of these others. I can create my own user attributes. We can define phasing, loading, and so on. I have the ability of how I want it to display things. When we get to doing some bent plates, we need to unfold something. I'll come in here to the display tab and I'll show you why we would utilize some of those selections. Full property data, here's some of that intelligent information that's on board. All right, we're seeing area of cross-section, we've got mass. We see the actual length for what I had modeled in there. I was just snapping point to point. If I didn't know what that dimension was, I could come in here and check that value if I needed that for some information. Gauge line information, how it actually looks at our connection macros, and in the case of our bolted connections on plates, we can see how it determines where to place those things. And other design information and so on. All right. That was one method, just simply point and shoot. I was choosing what type of element to model and snapping point to point. You would also find that we have the capability to do something called a beam from a line. So if I have one of those AutoCAD lines, I can simply start that tool, click my line or more than one. I can keep the reference information if I want or get rid of it, and the same process. All right, I get access to my properties. It's remembering that last assignment, right? It's changing the positioning if need be. Whatever the case may be called for, I can define those in the same process. I can always access my properties of any of these elements by double-clicking that item or right-clicking and getting to a context menu there. Right, so very quick and easy to model beams, columns, and so on. And just various AutoCAD typical approaches that we're accustomed to. But once we have some items in here and have begun to populate the frame of our model, all of our floor beams or whatever the situation may be, we need to move into our connection detailing. And that's really the value of what we're after here. We're doing steel detailing work. So as far as my connection vault goes, coming back to this, and note there is a favorites. If I have specific favorites that I use frequently, I can define that here. Then I can look at the particular groupings. If I come down to platform beams, I have clip angles, I have shear plates, choose an appropriate one. And let me also make a note that there's a flyout here that's very helpful to newer users to get familiar with a macro, or maybe a macro you haven't used in the past you think might be suitable. And it will tell you what the selection order is. I'm picking a beam and then a second beam that's connecting, so like a main selection and a secondary selection. It'll tell me what sections this macro will work on. And whatever it may be, and even allow me the ability to preview what that connection may actually look like for the condition. Okay, so they give us some kind of helpful pieces there. I'll pick my main, pick my second, and you'll see that it applies a connection and brings up a dialog box. And one of the great things about these macro dialog boxes is that it does let us edit on the fly for whatever the condition may be, but I can also see the changes. If I get a good position for us here, I can see the changes right on the fly. So let's look at a few of these properties. We can actually define that, maybe this is single-sided, so I could say which side is it justified upon. I'm changing left or right, or if it's a double angle connection. If I needed a different section, maybe instead of a 4x4, it's a 3.5 by 3.5, or if I have a long leg, whatever the case may be there. You'll have other properties we can set back. We're going to have control for coping distances and how it applies coping at top and bottom of the beam, whether we're having welds or not. We can define which member it's actually welded to, if doing so, full welded connection, whatever that case may be. And note, as I select different ones, defining whether it is shop welded or whether it's welded on site. All right. Like I said, cope connections. We even have little preview windows that help us determine, and it associates numbered conventions with us, saying, oh, okay, here's cope length, the cope depth, and I can see by the naming conventions we're presented, what is it actually affecting if I were to modify that value. Bolt parameters, if I had a different size I needed to choose than what was coming up. Grade, and whether the assembly itself, right, the number of washers being used, if washers and nuts are being used, so on and so on. Bolt locations, as I said, site or shop, you can see different ones, or if we have a site drill. Horizontal controls, separate controls for both the horizontal and vertical bolts in this particular case. I could go to vertical and I can tell it, well, which way am I setting this out? Am I doing it on the middle of the beam? Am I moving from the secondary or from the bolt positioning in each of these dimensions? I can change the grouping and number to get it to change the array, if you want to think of it that way, and the distance can be controlled. Again, looking at my preview window over here that indicate what value on the left is driving the dimension in the preview on the right. And one of the other things that's real valuable that has been in the product, but was a real value in release 2 of 2016 this year, is that Autodesk came back with a large number in our what we call a library. And what a library is it allows me to save any default configuration. So you can imagine if you start going through all of your connections here and you start defining unique instances and how I line things up, specific angle sizes, bolt spacings, bolt grade, and diameter, whatever it may be, I can save that so that I can come back and change it on the fly. And you'll note that in the library they provided us with different bolt definitions per size of beam. Gives us a good default starting point. So if I had a W12 in this case, I can simply select that, and this library will change it to what is saved and assigned. I can make that my default. There are some other tools that allow these to quickly connect and define connections for me. But having these library values saved is a huge time saver when it comes to detailing out every connection we might have in our whole project. It's going to work not just for steel connections here, but also consider as we look at stairs, railings, or other items, we may have library options that we can actually provide and recall as needed down the road. So if I were to actually come over here and find a particular one, select that connection, and however that one was placed or I had a design change, I can look at the joint properties of that one. And again, I'll see that library. And in that library, I say, no, I want to use a 2-bolt connection based upon a W10 section or a W14 section, whatever it may be. So a real benefit there in terms of how quickly it can connect these items. You'll see that in the model sample, we had some base plate items there already placed on the bases of our columns. We have column capitals we can put on. As far as diagonals and other gussets, you see a lot of these connections in the sample that are actually being placed by that same connection macro dialog box. Now, as we're progressing, we're probably going to want to add a lot more. Let me actually do a couple more beam from lines, and we'll work from those being kind of fresh and new ones here. I'll pick 3 line segments here, and I'm going to place those particular beam members, make sure they're positioned top of steel, and they are. I'll just stick with the section size it gave me. But not necessarily do I have to go in and pick one of these at a time. I actually have some tools that automate the process for me a little bit in how I might do replications of this. So if I successfully come in here, and I'll pick a particular connection box. You'll see I'm highlighting this connection box. That's the indicator associated with that clip angle connection. I could actually double click that item and get to my macro, just the same as if I were to pick any part of that clip angle connection and right-click and tell it to go to joint properties, right? So I can get to that macro either way. But in selecting this, I'm going to try to replicate this through a template or a group option. We have the capacity to do a multiple group option, single element that two of them are associated with one another, so that if you're familiar with AutoCAD groups or any other application that uses grouping, that way I can edit one and it changes all. In this case, I'm just going to do a single template. Excuse me. All right, so I have that particular object, and then I'm going to have to tell it its order of selection. Make sure I get it picked right. There we go. I'll pick this member, secondary member, and you'll see that it replicated that by a template. So very quickly I can start to apply those, and you can imagine with multiple it would be the same thing. I would just pick the particular order of picking, meaning main as first picks and then secondaries and so on, and I can edit those. If I would have used a couple of the other tools that are associated with the grouping procedure, then actually I would have the ability to edit one and update all in the same process. All right, so we have some capacity to do some quick connections there. But there is a tool for us for any connections that have not yet been applied. It's not one I often use. Let me make sure I find that here. All right, so we have, let's see, I think this is our tool, Quick Connection All. Now, inside of the application settings, it gives us the capability to define what our preferences may be. So it might, like the library shows you a 2-bolt connection for a W10, a 3-bolt for a W12, so on and so on. These things can kind of be defined as a starting point. If I use a tool such as the Quick Connection All, it will analyze the model for me, and it will apply any missing connections that are yet to be assigned within the model. And I've got a couple of here, and it will process those. Of course, this is one of those click and wait while you go get coffee. It takes a little time, but it's processing the entire model for us. And when it's finished, then we can go in and connect, check any of those connected items, make modifications as necessary, and it gives us a quick starting point. We could even take some quick information or take off and get a feel or an idea for just how much tonnage we're dealing with here, whatever it may be in a particular bill of material takeoff or a summary list that we might generate. But now we can see that all those connections, at least from the viewpoint I have right now, all of these possible connections have looked at those rules, that rule-based approach, and applied all those changes for me. All right. Let me come down here and look at a couple of other items. Let's just go into one of our particular connections and back to its, that might have been one of my others. Let's see here. All right, let's look at a couple of the other properties here. Let's see. Inside of my connection, I have a joint design tab for our macro. And if I'm looking at a quick design check, I have a couple of modules I can look from, the IFC, or I can look at the EC3 module. I have settings that I can assign for either of those approaches, what format it provides me to, because I can generate a report and a design check. Okay, I can provide input as far as loading conditions may go. What is my shear condition? Just putting in the values necessary, and I can provide a design check based upon some information there and see if this design is actually passing the verification or actually failing the connection, depending upon the conditions I'm assigning here and the design code being used. I can generate a report, and I can review that report. If any failures were occurring, I would actually see that in the status here, as well as any generated and exported report there. So that can be helpful for us. We're doing quick design checks in our connection detailing also. As far as clash detection goes, and the fact that I actually applied all of these connections, I'm not going to have any clashes, I would hope, as long as something didn't fail on me somewhere. So let me delete one of my connections by virtue of selecting one part, and I just hit the delete key. And you'll see that very visibly, I've got a collision right here just because of virtue of how we began modeling. It's not applying coping. There aren't any setbacks or offsets at this point. And inside of here we have different model checking tools, and we can actually do a clash check. So I'm going to pick a couple of members that I have a concern about. Maybe I have a very unique condition. And if I do a clash check, and I might want to do a selection, you certainly can do a clash check on the entire model. And the entire model might take a little bit of time to run, but once it's done, it will give us a full report of how many possible clash warnings or actual clashes that actually exist. You can select these items. This is, again, probably one of those that's better if reviewing from a wireframe display, so we kind of see the interaction. You'll note that the fact that I had double-clicked that, it does zoom to that, and we'll see that the clash is highlighted in red here. And that will indicate to me in a helpful way that, oh, okay, I see what I've got. At least it would allow me after, say, for example, quick connecting. I could come in here, and if something was missed, I could do a quick clash check on my model to see if there are any issues, and I could address those one at a time. All right. Let's move away from some of our connection detailing for the moment, and pull out here, and we have a line in my little sample model. You can see as I spin around, you can probably guess what's next. We're going to look at one of the powers of Advanced Steel in that I'm doing miscellaneous steel work. I'm going to create a simple straight run stair here and apply a railing on this. One of our hopefully future webinars, we're actually going to look at a little more in depth of the capacity it has for doing stair and railing capability. Let's look at this for the stair tool, just kind of in a simple approach. I will start that stair tool, and there are different command line options for me to define how I'm going to do this. A couple of different methods were given. I'm going to actually just use that line. That line was determined where is my start and end point. So I'm going to snap to those points. Oh, I missed my end point. I got to find my justification. I missed it, so let me do that one more time. Stair tool. All right, we'll hit that default, first point of the stair. Let me back up. I'll delete that one. Now I can start it again. All right, I'll select the default method, which is picking the start and end point. Okay, we'll just do a middle justification, which is the default indicator on my command line. And it will model the stair. It's going to pick up some default settings, and just like the connection macros, it's going to give us a macro for the stair itself. Again, I want to point out that library capacity. If I have anything defined in here, I could select these. Here you can say by tread type. I could give it any specific name I like just by simply editing these values and changing the name. Let's just walk through each of these and see what we actually have. We can see that I have a width value. If I desire, I can change that. And I can leave always the macro open. If that 4-foot stair fits between our two floor members here, then fine. But I can change width. The other values are filled in by the method of pick placement that I had defined. If I needed a different channel stringer section or another type, whether it's a solid plate or bar, or if I need a different size channel or a rectangular tube, whatever it may be, I can define my sections for my library. Tread type, we're given a preview window of several tread types. Some of these are users, so you can define your own user tread profile and select that in turn. I'll just pick a different one here. You can see how they highlight. Tells them which one I have. I can define different property values here. Tread dimension information, whether the angle setback, bending angles, and so on. And these previews don't change dynamically for the input values, but it simply gives us a static picture with the indicators of, you know, the 1, 2, 3 values as it applies in the macro window. All right, if I needed different distances, different lengths and sizes, I can define those. A particular angle for its what its supporting piece is, whether it's bolted, welded, and so on. Whether I'm defining a top step, bottom step, If I want to actually define stringer information and so on, we're going to, as we move through these, you can see that we have access to virtually every part and piece of this stair, and we can define that to our liking. This is definitely one of those I would want to use as a library. If I start creating different stair configurations, I want to save those so that I can change them on the fly as I create stairs. So I can make my bottom step the same as the others here, just by virtue of that checkbox. Pan down here so you can see that. Rotated that section. Let me move that back because we may not have gotten a chance to see that one. There you can see what it was given in the beginning. So I'll change that one. I can change the type or dimension if need be. If I want to define top or bottom landings, we're given a landing button, and I can actually extend these out, whether I see them or not. The visibility of these checkboxes and stringer size, if it happens to differ. Let's just make this 2 foot, just to see that extend. And then I could actually go and apply steel connection for where that intersects that supporting main beam, welded or so on. I could define cover. Let's not create the last tread, and instead we'll place a grating cover on here. So when I come over and make my cover, I'll choose either from plate or grate. And I could extend that to match, in this case, the stringer distance that I extended there. And then we could continue on that way to accurately define our stair. There are many options here. You can see how lengthy and all the different property values, but giving us the full capacity to get in and actually define what our stair configuration is for our particular project case. All right, so along with stairs, we're certainly going to want a railing tool here. And depending on my configuration and what I select, and actually before I place it on the stair, let's just make note that as long as we have a beam element, no matter what that beam shape may be, I can define railings very quickly and easily by picking these beam members. Let's just bring it all the way back from column to column there on that platform level. And I can pick my beginning and end points, whether they be nodes or snapping to other values, whatever it is. Let's pick my start and end point. And then just like on the stair, we have many options there as far as make sure I snap to the correct point. All right, and then we get a railing macro, just as we did with the stair. Very quickly can we put stair information, or railing information, sorry, in here. You can see that by that particular type, we're getting mitered cuts. We're getting cuts at our pickets and posts. We can space and change any of these posts as we need for the specific condition. If I've defined any other library items, I could pick at that time. If I want to define any specific handrail properties, middle handrails, hang-off rails, kick rail. I think this one has a kick rail. Let me zoom out here. Yeah, it does have a kick rail. Whether it actually has one or not, I could tell it to not use one. And as far as post connectivity goes, what is the connection type? Is this a plate with bolts or otherwise? Is it welded only? If I do a plate with bolts on top of these wide flanges, I probably need some offset. I need to change the number of bolts or the plate size in order to incorporate that. So let's go back to the stair itself. Let's put a rail on here just to see that it's looking for that beam association. And a stringer, as far as Advanced Steel is concerned, is another beam. Let me pick my members. Got to remember with the particular one I have whether I need to pick that or not. No, I think I don't. Let me make sure I unselect that one. And depending on the condition, I have to select appropriately to define this macro. I'm just going to simply pick these, and we'll see what we're getting for this slope condition. Again, similar fashion to what we looked at now I picked so far, that's why it's extending, but I can make alterations to that. Let's note at the bottom landing that we're going to have the capacity to actually, for the handrail, affect that end rail condition, whether it's a return, it's a bent, it's a loop condition, whatever that may be, all dependent upon those reference points that I gave it. And I have the capacity to actually extend this out in a horizontal return, change the height of how it returns to the post itself, radius values, cut values, anything we need to accurately define the makeup of that. So a quickly placed rail for that item. All right, I mentioned something about some foundation elements. Sometimes we need concrete pieces. So let's actually let's go to our other objects here. And inside of this, we have the capability of doing concrete columns, beams, walls I had mentioned. We actually have continuous and isolated footings. I'm going to do an isolated footing at this point. And I already have a base plate on this one, but I'll go ahead and just snap to a node. We'll see a placement on there. And then I could actually make changes as far as size go, just the same fashion as the other macro dialogues we've been bringing out. Maybe this is a 6 by 6 and 1.5 feet thick. Okay, we can change our concrete value, material being used. We can actually place concrete beams. We'll actually just pick a midpoint here that should allow me to snap for this particular condition. Just like our steel beams, I have justification control. And you can continue on that way to represent elements that you want to see in your anchor plan drawing. Okay. All right, let's look at some plate capacity here. I have a couple of references within the model, and if you can see clearly enough, I've got a couple of circular pieces in here, a couple of AutoCAD circles at differing elevation. You just select both of those and orbit around, you can see that. We're going to create a conical plate transition here. Just a conical transition by picking these two members. I tell I'm picking a contour. I could pick a beam reference if I had that and it was applicable. I can then break down just how many facets it has, the thickness of it. I think I must have mispicked that one. Let me try again. Contour. All right, I'll just put in 30 facets here. Let's change this to a 1/4 inch thick plate. You can justify this very quickly. Can it generate that transition for us? Let's do one more, and this time we'll go from a rectangular to a circular transition. Same tool, still sees it as a curve. All right, so I'll pick the contour again. That polyline, another contour being the circular, and let's do a rectangular to a circular transition. I'll use the same settings. And we get a nice transition piece here. Now, one of the benefits about being able to generate such a transition is that with its properties, I can actually unfold this, which when we get into very unique conditions and we need to detail these items out, how advantageous is it to be able to unfold and detail out our part, our plate, and actually see these bend points, any cut transitions. And these are editable. We can actually select these items if we need to define that a little bit differently for our fabrication process or for how we intend on making this output, then we can do that. We can get in and customize that element a little bit. You also have the capacity in similar fashion that if we have circular columns, beam members that we need to unfold, if we have it at there's a cut, skewed shape, something that maybe gives us an elliptical or parabolic shape on the end of a column, for example, or a tube brace or something, we can unfold those items to give us patterns that we can actually utilize to actually make that a little easier to fabricate in the shop. All right. Well, as far as modeling goes, I mean, it's quite straightforward. Obviously, we can run into pretty complex connection situations, but using the macros, or if we need to go beyond the macros, we can combine different connections into our own custom connections and getting the model to that detailed level is not terribly difficult to come to. But then we get to the point of where we want to actually define documentation and BOM schedules that are going to be useful to us, why we really want to do this. Again, if I look at properties of any of these items, and I look at the naming of any part that I've selected, you'll notice that for the single part or the main parts, we don't have anything defined right now. So I'm going to create a kind of a numbering situation. We have a numbering tool. We can match numbering methods for what it will be on our output sheets, whatever indexing we want to use. We have a series of numbers we like for a particular type of approach, say plates, for example, or otherwise. We can define that. We have different given numbering methods that we can utilize for both parts and assemblies. I can process that, and we'll look at the list that it generates. It's actually numbering everything within the model right now. We're going to get that dialog box here, and we can actually see all the parts and pieces as far as, in this case, all the main parts. Notice the prefixes that are given by my default setup, capital B for my beam elements. I might choose something different for columns or angles or whatever the condition may be, and all of these prefixes can be defined to your need. But in this numbering dialog, I can look at the single part marks. You notice the lowercase prefix values and the single part mark there. Well, I can close that, but once I've numbered and it's following my prefix definition, I can start to create other items here. So let's go to the Templates tab, and I'm going to create a material list summary for our model. I'm going to let that generate just to see how quickly it can give us some reports about items we have modeled for our project. All right, here we'll look at our list summary. You'll notice there's 11 pages in this particular schedule. We see all of these items grouped. We're looking at total length values. We're getting weight. A lot of valuable information very quickly just by virtue of the fact that we modeled those parts and pieces and modeled them accurately. Okay, material list summary. Similar to that, let me jump over and do another one. I'll save this. I'm going to show you where it actually stores all of that information. But let's generate a saw cut list from all of our model parts and pieces. And you'll see that for the shop, something very beneficial to us. If we have any unique cuts or copes or something, those will be defined in our little images and our previews for web and flange. We will see direction given on this if it has been defined. We see the marks, the size, the actual saw length. So we get a lot of valuable data and a report sheet that is very handy for when we move this to the shop and we're actually dealing with these. So I'm going to save that one as well. These items do get stored for us. We have something we call a document manager. We're going to also see drawings and other details in here. I hit my button right. There we go. All right, so details. Right now I don't have anything. That's why it says empty. I don't have drawings. But as far as lists go, there's my material list summary. I can see some property data about the particular file, or I can preview that just as we saw on screen. We can open these. We can export these to Excel or HTML format. We can print them, whatever's necessary for our purpose. All right. Before we go to some drawings, let's look at the capacity of fabrication support. All right. We have the ability to actually do NC data, DXF export. We could DXF all of our shapes, or we could DXF plates, a particular command that I'm going to use for you. But let's not pick all plates. There are a large number of connections in here. Let me just, I could filter, but let me just pick a few. I'll just pick a few items here. That should be enough for us. And we're actually going to generate some DXF of those selection plates. Tells me very quickly they've been created successfully. While I'm here, I'm going to go ahead and create the NC files, getting that ready for my extracts. And then I'll go back to my document manager. We can look in those areas. As far as our DXF files go for the plates selected, there we see, even with the piece mark, for those couple, I had similar ones that I had selected. We can look at the NC data. And if I need an NC1 file, that's a simple little setup. All I need to do is just define that in the configuration if I need a communication of an NC1 file. But I can preview the code information here. I can export and review that in an NC viewer. Okay, very handy to have all of that information. And I'd mentioned that this is all stored in kind of a project folder. And actually, if I move to that particular one, you'll notice these folders are created anytime I create a drawing file. That is that project, that modeling project. And we have folders for BOMs, any solid list, material list summaries I've done, any databases associated, drawings that are being generated, which we're about to do with single and main parts. They will be stored here. That particular exercise, I had done some drawing file creation. Any of our NC files, right there they are. If we need to send those independently, maybe we're outsourcing that. Other extracts in XML format and so on. So we have all of that data that we can share externally if need be, or if we just need a separate file to do so. All right, let's move into some actual documentation drawings. I'm going to do a couple of things here with what a little bit of time we've got left. We started a little bit late, so probably run a little bit over the hour since we waited for a few more people to join us. But let's look at creating some main part drawings. I'm actually going to not work my whole model because it is quite large. So let me just pick a few beam and column pieces here, and I'm going to go over to my drawing processes, and I'm going to use the method of assemblies. Assemblies give us the ability to see schedules actually apply to the drawing created. I'm going to tell it to, I can either tell it to do them each one per page, and I can pick the particular page size. However, I've defined that process setup with the prototype. I can tell it to fill up a page, and when it fills it up, it goes to the next sheet and continues on, whatever my preferred method may be for my document generation. I'm going to make a main part each on a C size here. Select that. Hit OK on my dialog, confirming those configurations. And once complete, I can go back to that document manager. And it will be listed in my details. So I can look at my up-to-date. Here are my main part drawings that were generated by the selection I made. Again, some property data if need be, what parts and pieces or stylization was actually used. You can open these drawings, AutoCAD drawings. You can edit them a little bit. You will need to do so. Sometimes the processes give us a little bit more, maybe dimensionally, than we need. Maybe we need to add something unique to a particular drawing. But you can also, just from the document manager, just preview the drawing that's generated here. Here we see the drawing number. The project information as my title block has been configured to define that. See bolt list information here for that particular assembly. In this assembly, it's defined to show me a top and a front view. I'm seeing spacings. There are some of those dimensions maybe I do or don't need. I might want to add something else a little bit different. Bolt holes, cutbacks, whether we need a reference dimension, automatic section cut creation from the element, and we see those generated here in our two sections, showing the clip angles, and the all-important bill of material at the top here for this assembly. Okay, and the mark association with that and what parts and pieces there are. And I can review each of these. I like using this preview tool quite a bit as opposed to open the drawing. But there's nothing wrong with that process either. Often we will edit quite a bit, or we'll add additional drawings or additional section cuts. Like here, I might even want to move that section down here a little bit. Okay. As far as maybe some single parts go, again, maybe I'll just pick a few plates. I could pick all my plates in the model, but there are quite a few, and I don't want to sit here spinning for several minutes while we wait on that automatic generation. So again, I'm going to pick some plate elements. And just as we did with selection of assemblies, I'm going to do single part marks. I could do drawing style, but I'm going to stick with my processes again. Processes are great if I can define a pre-configuration of what I want the application to do. I'll go to my selected options. Single part, I'm going to put one each on a B-size sheet. Confirm that if I needed to change anything for the arrangement of that. Wait for that to create my drawings. Go back to my document manager one last time. And you'll see the indication of the naming convention right here. single part indicator, kind of in the prefix of the file name. And if I would have selected all my parts, it would have been quite quick, although a few too many minutes for us on the webinar. But very quickly, can I create my plates drawings? This is one thing I usually see from a lot of my detailing houses that I'll visit with or consult to. Is like, wow, that would have taken me a long time to generate that. And here, just by virtue of our modeling process and using a documentation process setup from Advanced Steel, how quickly I can get plate drawings out and ready to go. And the fact that I have all the capacity of that miscellaneous steel support, that we have also the capacity to generate those plate drawings and things, connection details and so on. Big benefit to the steel detailer if we're just maybe using AutoCAD at this point. Maybe if you're using another 3D application, hopefully you've seen something here. You might have another question that would kind of clarify something for you. Let me take a moment here and I'll just check if there are any questions that I need to review. All right. Well, that is about it for all I intended on covering for this morning's overview. Again, we want to thank you. Let me bring up that last slide so you can see an email address where you can contact myself or Ryan Robbins, who is our sales associate. He and I work closely together for the Advanced Steel product. You're welcome to email either one of us if you have any additional questions. We do plan some future webinars in the coming weeks. We're going to focus, we've talked about stairs, railings, and some other connection detailing. I think possibly the next one may have to do with integration. The fact that we have the capacity to integrate with products such as Revit. Revit is a tool that I use quite a bit, and I can actually generate design models and move that right into the documentation toward fabrication process, how we can kind of streamline things. And we're going to look at that as well as with Navisworks, BEM 360, whatever other integrations we can find for you, possibly even Plant 3D and so on. But if you have any interest areas, please email Ryan or myself. Give us some information of things you would like to see, or if you have any questions that today's overview did not answer for you, then please, we invite you to go ahead and do so. So with that, let me check the dashboard one more time. And I see nothing else. So hopefully everyone have a good day, and hope you enjoyed the webinar. It gave you some information, and we invite you back for our next. Keep an eye open for any announcements. Our website at cadsoft-consult.com will post any webinars that are scheduled there as well, and you can sign up from our webpage. So with that, I wish everyone a good day and happy detailing. Thank you.